Happy Friday, everybody. Hi, Gretel. Hi, Haley. Hi, Morgan. All right, while we're waiting, it is Get to Know You Friday. We're going to talk about our favorite TV shows, and I will go first. I've got two. Well, I've got several, but one that I really, really like, and I find myself watching lots of repeats of, is The Big Bang Theory. I think those guys are really funny. But another show that I really like, and it's a little embarrassing, is the whole Bachelorette thing. But like, I'm okay with it because I'm 53, and if that's what I like to watch, that's what I'm going to watch. How about you guys? What would be your favorite TV shows? In case I need to start binge watching any shows again. Outer Banks, Friends. I'm always surprised how many young people like Friends. Teen Mom. That's the one on MTV, I think. My Hero Academia. Okay. Grey's Anatomy. That's been on forever. I haven't watched it in years, but I might have to with like the whole COVID thing. I'm doing it with the COVID. Hey, Caitlin. We're just talking about our favorite TV shows. All right. Well, that was good to hear. Let's just start with a quick little warm up. See if you guys can figure this one out. We are in week 16, and today's Friday, the 16th. Here is the warm up. Let's see if you can figure this out. Hi, Joseph. When Grant was 8, his brother was half his age. Grant is 14. How old is his brother? Hi, Ethan. Haley, you guys are pretty quick to hop on there. Anybody care to explain why you think it's 10? Caitlin thinks it's 7. Then Grant is 8. His brother was half his age. Grant is now 14. How old is the brother? Okay. Haley, because half of 8 is 4, that is correct. So 14 minus 4 is 10. That's a good approach. I thought of it a little differently. I started off as you did. I said, well, half of 8 is 4. And if he was 8 now and now he's 16, 6 years later, so I added 6 to the 4. But your method works perfectly well also. All right, so yesterday we did square roots. So there's a practice with that. That is due Sunday at midnight. There'll be another practice tonight with our factoring. That'll be Sunday at midnight as well. Hello, Denisha. As of this Sunday, if you hand in old work, you can still get full credit for it. But moving forward, so units 1 and 2, if you haven't done some work in there and you want full credit for it, you have till Sunday at midnight to get that done. Moving forward, though, I expect things to be done on time. Otherwise, it's going to be half credit after that. So anything here in Unit 3, if it's not in when it's supposed to be in, it'll be half credit when it gets in. So just kind of keep that in mind. We are going to start with our solving of quadratics. I'm going to start by factoring. Make sure you have some paper and a pencil. The first thing I want us to realize is, let's see here, that these terms, solving a quadratic, finding the zeros, and finding the x-intercepts all mean the same thing. So it's the same process for all those terms. If you hear any of those words, like say you're taking an SAT, PSAT, they all mean the same thing. So the first thing we're going to talk about is our graphs. And we learned this in the last unit. This is a quadratic in standard form, ax squared plus bx plus c. And we learned last time if a is positive, the graph opens up. And if a is negative, the graph opens down. So what I want you to do is look at these equations and say to yourself, okay, does it open up or open down? So this graph over here, because it is positive, is going to open up. You may want to just write a note to yourself on the side. You don't have to. It's just kind of more of a mental note. Can anybody tell me what the y-intercept of this equation is? We just took a quiz on all that. Like, what is the y-intercept? If we were taking the quiz, you would have said your A is 1, your B is -4, and your C is +3. All right, good. So our y-intercept is 3. So let's go ahead, put that on the graph. Anywhere on the positive side of the y-axis. These are just going to be very basic sketches. I am telling you the x-intercepts. Eventually, I'm going to show you how to solve for them yourselves. It's telling you the x-intercepts are 3 and 1. So on the x-intercepts means it's on the x-axis. X is 1, x is 3. And I want just kind of a basic sketch of what this graph will look like. I know it opens up. So that means we start up high. We're going to pass through that y-intercept, through the x-intercept, make a turn, and then head back up. So it's just a very basic sketch of potentially what this graph could look like. All right, let's try this again for number 2. Now when I look at this equation here, I don't know why that minus there. This is a plus. But I see this minus, which tells me this particular parabola opens down. What's the y-intercept for number 2? Jaden, you're quick today. Yeah, it's that C value. It's -15. Again, you don't need to write this, just more mental note. If it's negative, put it anywhere on the negative side of the y-axis. It's also telling us that our intercepts are +5 and +3. So let's go ahead and get them on there. So there's 3. There's 5. I'm not looking for scale or things to be exactly the right distance apart. So long as you're on the right part of the axis, it's fine. I know this parabola opens down, so it means we're going to start low. You want to pass through all these points. You go through the y-intercept, through the x, going to make a turn somewhere, and come back down. All right, let me give you a second on your own. I realize you can't put this in the chat by any means. I'll give you a minute just to kind of get a basic sketch of what this parabola, this quadratic, should look like. Hi, Caitlin. We're just getting started. All right, so here we go. I look at this equation in standard form. I see that the A is positive, which means this particular guy is going to open up. I also know that my y-intercept is -10. I am giving you the x-intercepts at this point. So we have one that's a +5. The other one's a -2, so it's going to be on the negative side of the x-axis. It opens up, so it means it's going to start high. We'll hit this x-axis, and then the y, make a turn somewhere, and then head back up. All right, so did y'all get that one? Not get it? Gretel got it. Jaden, you're good. Sometimes I don't know why I ask this question because very rarely does somebody who doesn't get it put it in there. Precious, you're good. Caitlin, Jerry. Okay, try the next ones. Try number 4. Okay, so let's kind of take a look at this one. Let's do green. I see that it's negative, so I'm making a mental note to myself that this parabola opens down. I also know that my y-intercept here is -8. I can see it, so we're going to put the -8 onto the y-axis. I am telling you that the x-intercepts for this particular equation are -4 and -2, so you want them on the negative side in the correct order. And again, that mental note, it's opening down, so it means you're going to start low, head through one of the axes, make a turn somewhere, and then make it through the y-intercept. All right, so that's just your basic graph. One part of the homework tonight is a matching section where I give you a factorization. Well, I'll talk about that a little bit. We haven't factored yet. All right, so far so good? All right, so let's talk about factoring. So I'm not going to give you the x-intercepts. You're going to have to find them on your own. And what we're going to do is we're going to do that through factoring. I'm going to keep the factoring kind of simple. I'm going to keep the a +1. So this piece up here will always be a 1. And the way we can do this is kind of by reading these equations backwards. And there's 2 different methods here. You do one thing when C is positive. You do another thing when C is, I should say, negative. Okay. So you want to start just by reading your equations backwards. So first thing you want to do is coming in backwards, you're looking for two numbers that multiply to be this number here, 12. And if this sign's a plus, add to be 7. So I think of all the factors of 12. There's 1 and 2. There's 2 times 6. And there's 3 times 4. Those are all the factors of 12. But I need numbers that multiply to be 12 and also add, because this is a plus, to be 7. So which ones would we be picking out here? Gretel, you answered even before I asked the question. Yep, it would be 3 and 4, okay? And when we factor, I think that's just a typo there, Jaden. What this guy here is called a trinomial, and you should have factored in Algebra 1. It becomes a product of two binomials. Because we're keeping a as 1, the front lead's always going to be x and x, because we multiplied back, x times x would get us x squared. So you want to pick the two numbers that we decided on, 3 and 4. You go ahead, just plug them in. And then you go back to your equation. It's kind of like a little roadmap telling you what to do. If this is a plus sign, it means the signs are the same, and they're both going to be whatever this sign is here. So in this case, they're both going to be a plus. Let me get the equation back in there. So let's go back. I want you guys to draw a little sketch. Let's go back to our original form here. I know this guy is opening up because it's positive. I also know that our y-intercept is a positive 12, so I'm going to go ahead and put that right onto the graph. We need to get our x-intercepts, and we do that by solving each part of this. So you're going to take each of these equations and set it equal to 0 to solve. And the reason we set equal to 0 is anywhere along this x-axis, the y is 0. So we're letting that become 0. Oops, I forgot the 0. Solve this by subtracting 3 to both sides. We get x is equal to -3. X is equal to -4. Get your x-intercepts on there. Make that a better dot. So it's opening up, so we start high. We come through one of the x-intercepts, make a turn through the other, and then through the y-intercepts. And again, this is just a very rough sketch of potentially what this quadratic could look like. All right, so let's see what happens when, well, actually, do we have any questions before I do when c is negative? Okay, it's almost the same process. We're going to go starting reading and backwards. Let's just grab some information off here first. This is positive, so I know I'm going to open up. I also know in this case our y-intercept happens to be -12, so it's going to go right about here. It's just a guesstimate as to where it goes. Reading our equation backwards, we're looking for two numbers that multiply to be 12, but if this is a minus, that subtract. So if this is a minus, I want those two numbers that multiply to be 12 will subtract to be 4. So here are our factors again. So which of these two multiply to be 12, but also subtract to be 4? Jaden, let me finish this problem and then I'll go back if it doesn't make sense from this one. I just saw your comment. All right, so we're all agreeing on 2 and 6. All right. So when we factor, we're breaking it up into a multiplication. We decided that it's going to be 2 and 6. If this sign's a minus, it means that the factors will be different signs. The signs will be different. And the bigger of these two numbers, 6 is bigger than 2, will take on whatever sign is in front of this 4. So it's going to be a plus and a minus. Okay, and Jaden, here's the part that you were asking the question over here. So once I know the factorization, you take each of these and you set them equal to 0 to solve. So we're going to take x minus 2, set that equal to 0. I'm going to take x plus 6, set that equal to 0. It's like solving a one-step equation. We're adding 2 to both sides. On this side, we're going to subtract 6 to both sides to cancel out, to isolate the x. What we found is the solution to the quadratic. We found its x-intercepts. We found its zeros. Those are all the same thing. Let's go ahead and plot. -6 is to the left of the origin. 2 is to the right. It says it's opening up. So we start high. We pass through this x-intercept, through the y, make a turn, and back up over here. And I realize that my sketch is not very symmetric, but these are just kind of hitting the highlights of this problem. I want to know whether it opens up or down, its y-intercept, and its 2 x-intercepts. Jaden, did that help with the other problem? With your previous question, not the other problem? Okay, so that's the lesson, right? From here on out, this is just pure practice. I've got 8 practice problems. We'll do a bunch of them together, and they'll give you a chance to try some on your own. Let's go to purple this time. So let's get some information that I need. Mental note, this guy is going to open up because we have a positive lead. We also know that the y-intercept is equal to this constant on the end, so we're going to go ahead and plot that. All right, we're going to start the factoring. It gets a little bit better without all the words in between. All right, reading your equation backwards, we're looking for 2 numbers that multiply to be 6. And because this is a minus, it's telling you what to do, subtract to be this number. So 2 numbers that multiply to be 6 that subtract to be 1. So think of 2 numbers that multiply to be 6 and subtract to be 1. All right, good. So we said there's always x's up front. I agree with everybody. It should be 3 and 2. And if you put the 2 here and the 3 here, it wouldn't matter. If this sign is a minus, it means the signs inside our parentheses will be different. And the bigger of these 2 numbers is going to be what this sign is. So the 3 is negative and the 2 is positive. Once you're factored, we're set to solve for our x-intercepts. You set each of these equal to 0 to solve. Adding 3 to both sides, we get x is equal to 3. Subtracting 2 from both sides, we get x is equal to -2. And if you guys can go from here straight to this piece over here, I'm okay with that, just so you know. What we found are our solutions to the quadratic. Our solutions are the x-intercepts, are also known as the zeros. So on the x-intercept, y is 0. On the left, we have an x-intercept of -2. On the right, we have an x-intercept of 3. I know this is opening up because it's positive, so we start high. We come down, we make a turn somewhere, and then through the other x-intercept. I missed, but I think you get the idea. All right, so taking a look at number 2. So looking at number 2 over here, what do we have going on here? All right, so I'm sorry, I just got a text and I don't think it's a good one. So what we have over here is a negative lead. My little game of saying, reading the equation backwards only works if we have a positive lead. So we're going to go ahead and take the negative out. And when we take the negative out, let me just switch colors so we don't confuse. It changes all the signs. So what's negative is now a positive. This was negative, it's now a positive. This is negative, it's now a positive. Okay. And now we've got a positive 1 lead, so we can do our factorization. Take that negative with you. And let's read in backwards. We're looking for 2 numbers that multiply to be 6, that add to be 5. So 2 numbers that multiply to be 6. If this is a plus sign, we want them to add to be 5. So let the equation be that roadmap for you. Yep, it is 3 and 2 again, oddly enough. Now it's a little bit different. If this sign is a plus, it means the signs are the same, and they're both going to be what this one is. So both of these are going to be a plus sign. All right, now I forgot to get a little bit of information from earlier. Up here, I know that my parabola opens down. And that our y-intercept is -6, so we can go ahead and plot that on there. All right, once factored, we set these guys equal to 0 to solve. I can see these are both on the negative side. You want to get them in the correct order. -2 is a little closer to the origin than -3. We're opening down, so we start low. We pass through an x-intercept, we turn somewhere, and then we make sure we make it through that y-intercept as well. Okay. Let's try another one. I'm going to do 2 more with you, and then we'll give you a few minutes to work on some. I look at this guy. Let's get the information that we need. We know it's opening up. You don't need to write that down. It's just a mental note. If it helps you to write it down, certainly go ahead. I know our y-intercept is a +5, so we can go ahead and plot that on the graph. Let's go ahead and start the factoring. We're looking for 2 numbers, reading it in backwards, that multiply to be 5. And if this is a plus sign, add to be 6. So 2 numbers that multiply to be 5 and add to be 6. This time it's not 2 and 3. Okay, good. We got 5 and 1. Again, if you put 1 and 5 or 5 and 1, it just doesn't matter. Just got to get the 2 numbers in here. That doesn't need to be there. If this sign's a plus, the signs are the same, and they're both going to be what this guy is here. So they're both going to be negative. Once factored, we set each of these guys equal to 0. Adding 1 over, we get x is equal to 1. Adding 5 over, we get x is equal to 5. We found the solutions, we found the x-intercepts, we found the zeros. They're all the same thing. Because I know we're opening up, we're going to start high. We got to get through all these 3 points in order, left to right. So this case can be the y-intercept, make a turn somewhere. and then through that last x-intercept. They should have arrows. They are continuing up forever. All right, let's do one more together. Let's try red this time. The first thing I notice is negative. That's going to tell me that it's opening down. I also know that my y-intercept is this number up here of positive 15. Get it on there. I need to factor, but I can only factor with a positive 1 lead. So I'm going to take that negative out. And all that taking the negative out does is change the signs of all three of these. So a negative becomes a positive becomes a positive, and this positive becomes a negative. We don't need the negative for anything other than direction. We're just going to use this inside here to do our factoring. Starting on this side, we're looking for two numbers that multiply to be 15. And if this is a minus, subtract to be 2. So two numbers that multiply to be 15 that subtract to be 2. Okay, Precious and Jerry think that they are 5 and 3. I do agree. 5 times 3 is 15. 5 minus 3 is 2. If this sign's a minus, the signs will be different. And the bigger of these two numbers, so 5 is bigger, is going to take on this sign here. So it's going to be a plus and a minus. We find our x-intercepts by putting each of these pieces equal to 0. Subtract 5 from both sides over here to get x is equal to -5 and add 3 here. These are our solutions. Our x-intercepts are zeros. -5 is to the left of the origin. +3 is to the right. We know from the original standard form it's opening down. So we start down, we come up, we make it through the y-intercepts, it makes a turn somewhere, and comes back down. All right, does anybody have any questions at this point? Okay, and if you are, don't be like embarrassed, throw it out there. All right, let me try this one. Remember, it's a negative. You're going to have to pull that negative out. Work on that for a few minutes, and then I will do the problem with you. All right, guys, so let's kind of take a look at this. Before we start factoring, let's get the information that we need out of here. We know it opens down. Can't do anything with that right now. It's just a mental note. We also know the y-intercept is -6. I know I can't factor with a negative lead, so we need to factor that negative to the front. Essentially, what that does is just change the signs of all three of these. Since they're all negative, they're all going to become positive. We bring the negative along. It doesn't do anything as far as helping us with the factorization. It's just, again, showing direction of the parabola, the quadratic. We're looking for two numbers that multiply to be 6. And because this is a plus sign, add to be 5. And we did this one earlier. We decided it was 2 and 3. If this sign's a plus, the signs will be the same. And they're both going to be whatever this guy is here. So they're both positive. Setting each piece equal to 0 to solve. Here we get x is equal to -2. X is equal to -3. That's a negative. We get -3, -2. It's opening down. So we start down, and we got to go through all three of these. So it's going to make a turn here, and we start heading down, 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 down. And that's just a really rough draft of what this parabola looks like. How'd you guys do? Okay, the nice thing about this is a process to it. You know, you're not kind of randomly guessing. Try number 6. I'll give you a minute. I'm just going to do attendance while you guys are doing that. What do we need? E-school. This is block 4. I don't want that. I want attendance. So Jerry here. Lexi is not. Victoria is not. Robert is. Ethan is. Is Kitana here today? I don't think I saw him. Riddle's here. Matthew's not here. Haley, Rachel's here. I don't think I saw Claudia. Jaden's here. Joseph's here. Ernest in here? Yeah. We have Ernest. Nope, he's not here either. Bryn's not here. Jeremy's not here. Half this class is not here. You guys have terrible attendance. Well, not you, because you're here. Is Eric in here? Nope. Morgan's here. Caitlin Walls is here. I don't think Kasha's here. Precious is here. And Caitlin Watson's here. All right. I know it's Friday and it's raining, but people should come to school. All right, so let's try this one together, guys. This one's positive, which means that it is opening up. I also know that our y-intercept is a +12. So we'll get that on our graph. Since it's positive to begin with, we don't have to worry about factoring out that negative. We're just going to start the factorization. We're looking for two numbers that multiply to be 12, and because this is a plus, add to be 7. And what did you guys come up with when that? Two numbers that multiply to be 12, that add to be 7. Good, we came up with 4 and 3. If this sign's a plus, the signs are the same, and they're both going to be what this one is. So it's going to be minus, minus. To actually go ahead and solve, we set each piece equal to 0. So here we get x is equal to 4, x is equal to 3. Those are both positive. They're going to be on the right side. And again, we're not worrying about scaling or pacing. Just get them in the right order and on the right side. Since it opens up, we start high, turn around, and come back up. All right, we've got 2 more. Just do number 7 for now. Let's just go one at a time. I'll give you like 2 minutes to work on that. All right, you guys ready? Does anybody need some more time? Nobody's answering me, so I'm just going to go ahead and get started. Let's do blue. All right, this has a positive lead, which means it opens up. That's just a mental note. We look for the y-intercept. It's that c value. It's coming from negative 24. To get our x-intercepts, we need a factor to solve. We always start with x and x. We're looking for two numbers that multiply to be 24, that subtract, because this is a minus, it's telling us what we're looking for, that subtract to be 2. So two numbers that multiply to be 24 and subtract to be 2. What did you guys come up with? So we came up with 6 and we came up with 4. That's what I would have gotten as well. If this sign's a minus, it means the signs are different. And the bigger of these two numbers, so 6 is bigger, is going to take on this sign over here. So that's going to be the plus, and this will be the minus. Setting each piece equal to 0 to solve, to actually do the solving, because I want to know where y is 0. Here we get x is equal to negative 6, and Here, x is equal to positive 4. So negative 6 is on this side, positive 4 is over here. It opens up, so we start high, go through this guy, coming down, make a turn, and head back up. So very, very rough draft. All right, number 8 is our last one for today. Make sure you get that negative out. I'll give you an extra minute to finish that one up. All right, so let's see what we get. Looking at the equation itself, important information. It's opening down because it's negative. We also know the y-intercept is -9, be around here somewhere. These are just guesstimates. In order to factor, we need to get rid of that negative out front, so we're going to factor it out, changing all the signs. So negative becomes a positive, which is what we need in order to factor using our little going backwards rules. This positive becomes a negative. This negative becomes a positive. Moving the negative along with us. Reading inside of here for this trinomial, we're looking for two numbers that multiply to be 9. And because this is a plus sign, add to be 10. So two numbers that multiply to be 9 and also add to be 10. Haley and Jerry and Precious, y'all got 9 and 1. If this sign's a plus, it means the signs are the same, and they're both going to be what this guy is here. We can now solve. Go ahead, put each one of these pieces equal to 0. Adding 1 to both sides. So 1's pretty close to the origin, 9 be over here somewhere. We're opening down, we're going to go up and then make that turn to come back around. So up, up, turn, and we come back down. And that is how we solve our quadratics through factoring. All right, so any questions? Okay. All right, awesome, guys. I'm just going to take this down for a minute. We did that. So again, if you're in your week 5 folder, you should have 2 activities that are due Sunday at midnight. And again, if they're not in on time, then they're going to be half credit. So make sure you're doing them. You're going to have one on the perfect squares. You're going to have one on these quadratics. Let me make sure it's open. The other class said it wasn't open. So let's just double check. Make sure you can enter in the information. Yep, we're all enabled. You're good until 12:01 a.m. on Sunday. If at any point during the weekend you have questions, please feel free to send me your work through Remind. I can answer them there. Doing a lot of things Saturday. Can't promise I'm going to answer right away, but I certainly will get back to you. If you're missing work from units 1 and 2, you have until this Sunday to get them in and get full credit for them. A couple of you handed them in. Gretel, I think I've updated all your stuff at this point, but I'll double check through everything. I still need people to take the quiz. Who's here? Robert, can you take the quiz today at 1:45, the test? If you don't do it today, you need to do it next Wednesday during office hours. Isaac, Matthew, Claudia's not here. Bryn's not here. Jeremy's not here. All right. And Caitlin, we chatted yesterday. Oh, you're welcome, Gretel. Make sure I got everything, okay? It's hard in this electronic format. Like, I think I've got everything. I miss paper, just marking them off, writing them down. But all right, it's Friday. If you don't have any questions, I think we can end a few minutes early. Have a great weekend, everyone. Make sure you get your work done.